Now, welcome back. We are going to start with the first topic of the day, and that is what? Quantum number. I call it quantum number. In quantum chemistry, quantum number. What is quantum number? Quantum number can be defined as the set of values that give an acceptable solution to Schrödinger wave equation for hydrogen atom. I come again slowly. Quantum number is the set of values that gives an acceptable solution to Schrödinger wave equation for hydrogen atom. Now let me define it in a more simpler way for your understanding. Quantum number can also be defined as the address of an electron in an atom. I come again. Quantum number can also be defined as the address of an electron in an atom. Now, there are 4 sets of quantum number, but before then, if you wish to go to Enugu State and you have not been to Enugu before, you want to go there and see your brother, with a good address, you can locate your brother. In the same way, every electron in an atom has an address through which it can be what? Located. That address of an electron in an atom is called quantum number. So now, there are 4 sets of quantum number. The first is what? The principal quantum number. The symbol is what? N. In quantum chemistry, N is what? Principal quantum number. Make sure you have your pen and paper and make sure you are jotting. Now, the second one is called the azimuthal quantum number. That's number 2. And the symbol is what? L. Please remember that azimuthal quantum number is also called subsidiary quantum number. But remember that the symbol is what? L. Now the next quantum number is what? Magnetic quantum number. So that's the third one. The symbol is what? Small m. And the last one is what is called the spin quantum number. And the symbol is what? S. So these are the 4 sets of quantum number. Now we are going to be explaining them one by one. At the end of each topic, we are going to solve all the possible jam questions in each topic. So you are what? We make sure we provide you with everything you need to make your jam once and for all. The same thing happened to first year courses. Alright, let us start with the first one, principal quantum number N. The principal quantum number is used to determine the major energy level of an electron in an atom. Alright, we proceed with the principal quantum number. Now, like I said before, the principal quantum number N determines the major energy level of an electron in an atom. It takes an integral values of N is equals to 1, 2, 3, 4, and so on and so forth. So the principal quantum number takes an integral values of N is equals to 1, 2, 3, 4, and so on and so forth. Let us now look at the azimuthal quantum number. But before then, remember what I said about the principal quantum number. In case if you have forgotten, let me also refresh your memory that the principal quantum number determines the major energy level of an electron in an atom. And I said it takes the integral values of n equals to 1, 2, 3, 4, and so on and so forth. I also told you that the principal quantum number is used to determine the major energy level of an electron in an atom. How? Now take a look. E is equals to minus square over n squared. Where this E is what? The energy of the electron. So with the principal quantum number, you can find the what? Energy of the electron. K is what? A constant. So that's why I said that the principal quantum number is used to determine the major energy level of an electron in an atom. Alright, we now go over to azimuthal quantum number L. We now go over to azimuthal quantum number L, also known as what? Subsidiary quantum number. Now the azimuthal quantum number is used to locate an electron using the shape of the orbital. I come again. The azimuthal quantum number is used to locate an electron using the shape of an orbital. Now, I repeat again for the last time. The azimuthal quantum number is used to locate an electron using the shape of the orbital. Alright. Now, if you look at s orbital, the shape of s orbital is what? Spherical in shape. If you draw the shape of s orbital, this is how it is. This is your y and your what? X axis. And this is what? S orbital. So remember that s orbital is spherical in shape. Now, p orbital. Let us look at the shape of p orbital. Remember that p orbital is of what? Three types: px, py, and pz. As we proceed, I will be showing you these three p orbitals. Now, the shape of p orbital is what? Dumbbell. So p orbital is what? Dumbbell in shape. If you draw the shape of p orbital, we are going to have something like this. If I draw the first one, this is your what? X, and this is your what? Y axis. Now to draw this what? Z. So this is a dumbbell, and this is what? Px, because the dumbbell is facing what? X axis. So I call it what? Px. Now to draw my Py, we have something like this. This is my X, my Y, and my Z. So because I want to draw Py, the dumbbell will face the Y axis. And this is what? Py. Now to draw my Pz, then I will have something like this. Remember, the dumbbell will now face what now? It will face the Z axis. So this is my what? Pz. So, in summary, we are saying that p orbital has what? Dumbbell. And these are what? The three dumbbell. Now, s orbital is spherical in shape. Now, having known this, let us now look at d orbital. Now, d orbital is double dumbbell. And what do I mean by that? If you look at the structure of d orbital, we are going to have something like this. So this is what? Double dumbbell. And that is the shape of the orbital. So please try to know all these things. As you are watching this video, remember to pause it when you feel like thinking more. You can pause it. Also make sure you have your pen and paper to be jotting all these things, because catalysts have a lot to give you. Now let us now look at the relationship between the principal quantum number L and the principal quantum number N and the azimuthal quantum number L. Now the link is what? That N is equal to L minus 1, such that when L is equal to 1, then N becomes what? 1 minus 1, and that's what? 0. When L is equal to 2, it means that my N is equal to what? 2 minus 1, and that's what? 1. What I'm doing is what? I'm trying to substitute for value of L in this formula. So, when my L is equal to 3, then my N becomes what? 3 minus 1, and that's what? 2. When L is equal to 4, my N becomes what? 4 minus 1, and that is what? And that is a 3. So, from these values, when L is 1, N is what? 0. Okay? To give you. Now, let us now look at the relationship between the principal quantum number L and the principal quantum number N and the azimuthal quantum number L. Now, the link is what? That N is equal to L minus 1, such that when L is equal to 1, then N becomes what? 1 minus 1, and that's what? 0. When L is equal to 2, it means that my N is equal to what? 2 minus 1, and that's what? 1. What I'm doing is what? I'm trying to substitute for value of L in this formula. So, when my L is equal to 3, then my N becomes what? 3 minus 1, and that's what? 2. When L is equal to 4, my N becomes what? 4 minus 1, and that is what? And that is a 3. So, from these values, when L is 1, N is what? 0. Okay?